This video here we're showing how to create a systems of equation from a table. The prior video we used was when we had the y-intercept. This one there's no obvious y-intercept in the table. So we're going to try to use the point slope form to create our equations in slope-intercept form. So if you notice, this one isn't two separate tables, it's one combined. And if you kind of notice, we have an x and a y1 for one order pair on this side, and over here we're going to use the same x, but we're going to use y2 as our other order pair on the other side. So we're going to create two tables. Alright, so we're going to create these two tables, so that would probably be a little easier to see, and then we'll go from there. We'll call this one table 1, and we'll call this side table 2. And all we're going to do is take the table you see in the middle and we're going to split it, kind of separate it. Alright, so we have our x and y1. So we have -4, -3, -2, -1, and 1. And their y values is going to be 10, 7, 4, 1, and -5. On table 2, we're going to still have x, the same x value, but we're going to use the y2 numbers. So the x values will be the same in both tables. And the y value, however, oops, sorry, I put the wrong one. The y value will be the values in y2. So we got 12, 8, 4, 0, and -8. So what we've done is we've taken this table and we've just converted it into two other tables. Now what we're going to do is we're going to convert the tables into, we're going to create an equation from the two tables. And we're going to put it in slope-intercept form. So the first thing we need to find is the slope. And then we're going to need to find the y-intercept. And the best way to do this, since we don't have x equaling 0 here, then we're going to use the point slope form. Now there is an easy way to find the y-intercept here, but we're going to try to find, this video is to help you in case you can't find it. Alright, so what I've done now is I have moved the two tables, and we're going to find the slope for each one. So remember, the slope is y equals y2 minus y1 over x2 minus x1. And we do that on both sides. Alright, so we can pick a point, and so I'm just going to randomly pick a couple of points here. Let's see here. I'll pick -2 and 4 as my 1 point, and then I'll pick -1, 1 as my second point. So this will be my y1. This will be my y2. This will be my x1. This will be my x2. On this side, we'll pick, these look good, -2 and 4, and this will be -1 and 0. So we're going to say this is going to be my y1, this will be my y2, this will be my x1, this will be my x2. Now you probably noticed that I have -2, 4 in both things. That means these intersect, they have something in common. And so when you talk about the solutions, like we talked about in another video, since these are connecting right there, that is our solution. That's our answer. So it's a single point solution because they intersect at that table, which we'll get into later. Alright, so I'm going to go ahead and find the slope for each one. Now I'm going to go ahead and just plug these in, and I'm going to use a different color to kind of separate it. So my slope equals, my y2 on the first table is 1 minus 4. Then my x2 is -1 And remember we have a minus here. And then my x1 is a negative 2. So I actually have two negatives right there, which is going to make a positive. So I'm going to clean this up a little bit so you can see it. Otherwise, I'm just going to rewrite it for you. So 1 minus 4 is a negative 3. And this would be negative 1 plus 2. Now, if we did our math and we did everything right, we should have negative 3 over 1. So my slope is going to be a negative 3. Alright, so let's do this side. So my slope is, my y2 is 0 minus my y1 is a 4. My x2 is a negative 1, and don't forget we're subtracting. Let's just subtract there. So then we have a negative 2 here. And this is the same situation we had before. So we got a negative 4. And this is going to be a negative 1 plus 2, which looks like it's going to be negative 4 over 1. So my slope is going to be a negative 4. Alright, now I'm going to convert these. These are both my slopes. Now I'm going to convert these into, I'm going to use them in the point slope form. Okay, so what I've done is I've kind of cleared the screen up so you can kind of see it better. So now this is our two slopes and our table. We want to put it in point slope form, so I'm going to write point slope form down here. And we're going to do it on both sides, so I'll just write y equals y minus y1 equals m times x minus x1. Okay, that's going to be for both sides. Alright, and so if you notice we have a 1 here on both the x and the x1. We only have a 1, so that means we only need 1 point. Catch the clue, point slope. We have the slope, we just need 1 point. And I don't know about you, but I kind of like one negative 1 here. I'm going to do this a different color because I didn't like the color there. Do that color right there. I'm going to use that as my point. This will be my y1. This will be my x1. And over here, it doesn't matter which one I pick again. I like negative 1, 0. And so this will be my y1 and this will be my x1. So I'm just going to plug these in. So y minus, my y1 is a 1. My slope we said is negative 3. And now if you kind of be careful here, we have a negative, but we also have a negative 1. And so we talk about this, that's going to be a positive. So I'm going to clean it up a little bit, make it look nicer. So I'm going to rewrite it. So it's going to be y minus 1 equals a negative 3x plus 1. Now we're going to use the distributive property. So I'm going to multiply negative 3 to both of these. So this is going to be y minus 1 equals a negative 3x. Negative 3 times 1 is a negative 3. Add 1 to both sides to get it into slope-intercept form. So this becomes y equals a negative 3x minus 2. So that right there is our slope-intercept form, which would be nice if we wanted to graph it. Alright, so we're going to go ahead and do the other side. So we're going to plug everything in. So y minus my y1 is 0. That's very nice. My slope is negative 4. X, and then again we have the negative, but we're putting in a negative 1. So that's going to make those two, these two guys turn into a positive. So we're going to again rewrite it so it looks a little cleaned up. So it's y, and I'm not going to put 0, I'm just going to put y, minus 4x plus 1. And you should be able to guess that we're going to distribute the negative 4 to both sides, or to everything in the parentheses. So we get y equals a negative 4x minus 4. Again, there right there is our slope-intercept form. So we could graph these, put these in the calculator, and it could graph for us, and then we could see that these two lines will intersect somewhere. And according to what we looked at the table earlier, we could tell that these two would intersect at -2, 4. All right, so these are in slope-intercept form. But what if I wanted to change them into standard form? Which is easy. We're just going to move the x over and clean it up, and we should be good to go. So I'm going to go ahead and alright, so now I'm going to change these into standard form. Like we said, we want to put it standard form, if you remember, is putting the x and y on the same side of the equal sign. That looks terrible. I'm going to rewrite this for you guys. So standard form, if you remember, is ax plus by equals c. And we don't want the a to be negative nor positive. So we want the x and y together on the same side of the equal sign. So I'm going to move my x over. So it's a minus, so I'm going to do the opposite, which is plus 3x to both sides of the equal sign. So this one will be 3x, and since this is a plus y, we're going to make it positive y, or plus y equals a -2. Now, we're going to do the other side. We're going to subtract or add 4x to both sides. And I'm going to erase this so we can see it better. And so this will be 4x, 4x plus y equals a -2. Now these two guys here are now what we call our systems of linear equations. They're two equations with variables, with similar variables, or two different variables. They both got an x and y in it. And this right here would be our systems of equation. Now remember, we could have used the y-intercept forms as well.